Alrighty, in today's lesson, we'll be talking about one of the very big apologize. I have a little technical difficulties. Let's see if I can get this. All right, here we go. Looks like everything's working now. So again, greatest common factor is the very first thing. Again, we're being 1.6 factoring polynomials. Do apologize for the sound. And then we're going to talk about factor by grouping. So then you have again, you typically do this when you have four terms. Then we'll have special cases. This is your, difference of squares. And your sum and difference of cubes. Notice you had it for squares, for sum, and then cubes has both sum and difference. And then we'll just talk about just generic trinomials. The book uses the AC method. There's a lot of methods out there. I'm going to actually show you one that I like. Don't not prefer. There's like 15 ways to do it. But I want to make sure I show it to you so that you can have a different example as well. Again, the book will do the AC method, but I like to go into more specific on what I call the fractions. All right, so I think that's a bit it. Oh, the only thing I want to talk about is the special cases, these difference of squares. So let me get a little bit more in depth in this one. So we have a difference of squares is just written as a squared minus b squared. That can be written as a minus b and a plus b. You can go forwards and backwards. So last section we saw when we multiply it, we can get this. So same thing. If you notice that's a difference and they're perfect squares, we can break it up. Sum and difference of cubes. So your difference of cubes. So if you have something like this where you notice they're perfect cubes, you can write it as a minus b times a squared plus ab plus b squared. The way you can remember this as well is what we call SOAP. SOAP is broken down basically as the same sign, the opposite sign, and then always positive. There you go. So same, opposite, always positive. And that kind of help you remember it. So like if I have the sum of cubes, it'll be the same setup, except I'll have a plus sign. So this will be a plus b times a squared plus ab plus b squared. Oh, my bad, not plus. It should be minus for the opposite. So we got the same sign, opposite sign, always positive. All right. And again, they have the AC method in the book. I'm gonna use a method. I really don't know what it's called, but it deals with fractions. I know you might not like fractions, but these fractions are pretty straightforward. All right, so let's just go ahead and jump right into this. Let's look at number 5 on page 67. All right, this is going to be problem number 5. So this says 2x to the 6th minus 14x cubed plus 8x. So do pay attention to what the questions are asking so you don't end up doing too much and beating your head trying to figure it out. These first set right here, it simply says factor each polynomial by factoring out the greatest common factor. That is all they're wanting you to do here is just do greatest common factor. Best way I do this is look at the coefficients, pick the smallest number, and ask yourself, does that number go into the other two numbers? If it doesn't, then you try to find factors of that small number and then take the largest of those factors and ask your question again. So 2 does in fact go into 14 and an 8. So that tells me that 2 is my greatest common factor. Then look at the common letters. I see that they're all x's and choose the smallest exponent. So in this case, there's an imaginary 1. That would be the greatest amount that you can take out, is the smallest amount. All right, so that means that the 2x will become my greatest common factor. Then you just have to simply write what is left. So 2 divided by 2 is 1. And if I take an x away from x6, I now have x to the 5th. So again, you're basically just dividing. So again, 2x to the 6th divided by 2x becomes 1x to the 5th. Negative 14 divided by 2 gives you negative 7. I take an x away from x cubed, I have x squared. 8 divided by 2 gives me 4. If I take an x away from an x, I no longer have any more x's. And so there you go. All right. Next one I want to look at is number 9. Now, why this question kind of comes up is to kind of lead us into the next stuff, but it starts off pretty simple. It has starts off with 12y to the 6th minus 8y squared minus 16y to the 5th. And then all you're going to do is in 9 is not exactly like 9. This is it looks more like this on your homework. So it has this right here. It's not talked about in the book, but it's a lead way into the next set. So go ahead and just talk about it right now. So again, it's like 9, but it's not actual 9 because I added this 2y. So you don't always do this. But what we're going to do is to simplify this expression. So you basically have to divide the 2y to everything. So it kind of looks a little bit like this. So again, this is not in the book, but it is in your homework, and it's the lead into the next thing. So when I do this, you just simply divide it. You don't have to write it out like this, but I want you to see what's going on. So 12 divided by 6, my bad, 12 divided by 2 is 6. And if I take 1y away from y6 or subtract like basis, 6 minus 1, I get y to the 5th. 8 divided by 2 gives me 4. 2 minus 1 is just 1y. 16 divided by 2 is 8. 5 minus 1 gives me y fourth. So this is what the answer would look like on the homework concept, but not specifically to this one here on factoring. But that's what the homework is going to look like. All right, number 11. It says factor each polynomial by grouping. So this concept only works when you have 4 terms. Now, in this concept I'm about to do, you can rearrange any of the terms to make it work out better for you. I'm going to stick it with this and just see what happens. So what I do is I group up the first 2. If I have a minus sign, I'm going to say plus a negative, and I'm going to group up the last 2 terms. Then I'm going to look at the first 2 terms and go, what's the greatest common factor? I notice they both have an a, and this one has only one a, so one a can come out of both. If I take an a from a cubed, I'm left with a squared. If I take an a away from ab, I'm left from b. Then when I look at this rule of thumb, if your first leading coefficient has a negative, go ahead and factor out a negative. And then look at the rest and see that you have a b for each. So I'm going to take out a b. And so if I take a negative, this result will now be positive. I'll still have an a squared, but now no b's. If I take a negative factored out, this now becomes positive. And if I take a b away from a b, I now have one b. All right. The purpose of factor by grouping is to make these two binomials exactly the same. And then what you're doing is you're going to factor out the a squared plus b. So this is your greatest common factor. And now you're figuring out what's left. So if I take an a squared plus b away from a times a squared plus b, I'm left with just an a. If I take out an a squared plus b out of the b times a squared plus b, I'm just left with that minus b. And then that right there would be your result. All right, let's look at some special cases. Let's look at number 21. 21 says 49a squared minus 144b squared. So now this does say special cases, but it might not always on your test. So you just kind of have to look at it. If it's a binomial, is it a perfect square or a perfect cube? If it's a perfect square, like this is here, I can see that they're a square, so that's my only potential. Make sure it's a difference. So here we go. So to determine this, I'm going to use the a squared minus b squared equals a plus b, a minus b. The order of this two binomials does not matter. So then I'm going to take the square root of both sides. So the square root of 49 would give me, so the way this works is what you're trying to do is you're trying to determine your a and b. So if this represents my a squared, the square root would represent the a's that I need to put in first. Square root of 49 is 7. Square root of a squared is a. So my a ended up being 7a, which would represent the a's right here. Then I do the same thing over here with the b's. I got one with the plus, one with the minus. Again, that order didn't matter. But the square root of 144 is 12. And then the square root of b squared is b. So therefore, I just factored out just using my formula. Let's look at another one. Let's look at number 29. 29 is 27x to the 6th minus 8y 12th z cubed. All right, just looking at this, I can just assume because of that 3, it's probably not going to be a square. So let's try to do a cube. Now see, there's a difference. So the difference of cubes, remember, is the same sign, opposite sign, always positive. So in this case, I'm going to do the cube root. So the cube root of 27, so that'd be one number times itself 3 times. So that would be 3, 3, 3. So that's 3 times 3 is 9, times 3 is 27. So that would be 3 minus, I'm plugging in this part right now. Actually, no, I'm not done with it. So 3 then goes into 6 2 times. So that'd be 3x squared. So it went into it evenly. And then now I can go minus. And then 3, the cube root of 3 would be 2. So that'd be 2. 3 goes into 12 4 times. So that's y to the 4th. 3 goes into 3 1 time. So that's just z. So that's that first part. And then you just keep plugging it into the next one. So this is going to be 3x squared. So that 3 is now going to become a 9. And that square is now going to become a 4. Because again, this was 3x squared squared. That was that a part. Plus a times b. So that's going to be this 3x squared times the 2y 4th z. So I'm going to write that as best as I can, but that'd be 6x squared y 4th z. I always find best practice, put it in alphabetical order. And then that last part, always positive. And then now I have 2y to the 4th z squared. So I apply it to each thing. So 2 squared is 4. Y to the 4th squared would be y to the 8th, because you power to power, you multiply. And then z squared would be z squared. And then that trinomial here cannot go any further, so that would be your answer. Let's look at another one. Let's look at number 32. 32 is 512 x to the sixth plus 729y cubed. Well, two things. One, it's no longer a difference. So if it can be simplified, it can only be a cube. And I have a 3 here, so that tells me it's not a square either. So again, looking at sum of cubes, same, opposite, always positive. All right, so now I'm going to take the oh, there we go, cube root of this. So the cube root of 512 might be where a calculator can come into play. Let's see. It can't be. So maybe I'm thinking 8. Let me get a calculator out. So 64 times 8, 5. Okay. So this would be 8. So 8 times 8, 64 times 8 again would be 512. So that would be parentheses 8. 3 goes into 6 2 times. Same sign, so that'd be a positive. 729. Oh gosh, that gotta be a 9. So 81 times 9 would be 729. So 999. So that gives you a 9. Cube root, or 3 goes into 3 one time. Now I can write out the rest of the result. So this is going to be 8x squared squared. So that would be 64x to the fourth, because you apply it to both, minus 8x squared times 9y. So 8 times 9 is 72. And then again, alphabetical order, plus 9y squared. So that would be 9 squared would be 81, and then y squared. And so again, that would be your final answer. All right, so let's get into the meat of actual factoring, which is factoring trinomials. Let's look at 35. We'll start off with trinomials with the leading coefficient of 1. They are the easiest. So the way you want to do this is considered to be A, B, C. So you want to multiply to your C and add to your B when it's written like this. So multiply to your C and add to your B. So my C here is negative 15 and my B is 2. All right, so you can guess some numbers until it works, but mathematically what you're doing is coming up with all of your multiples of 15. So that's 1, 15. 2 doesn't go into it, 3 and 5, and that's pretty much it. The fact that it has to be negative tells you that one of these has to be negative, and you want it to add to a positive 2. So that tells you that the smaller number would be negative. So negative 1 plus 15 is 14, and negative 3 plus 5 would be 2. Well, there's your winner, so there's your factor. So then a trinomial will always factor into 2 binomials with the leading term of x. And then now you just write your factor. So minus 3 plus 5. If you said plus 5 then minus 3, you're still correct. All right? Let's do another one. 36 is x squared plus 6x plus 9. In this one, again, we're trying to multiply to our c, which is equal to 9, and we're trying to add to our b, which is equal to 6. I go through all my multiples of 9, so that's 1 and 9, 3 and 3. And since I'm adding to a positive, that tells me they're both positive. So this gives me a 10, which is not right. 3 gives me 6. And there's my winner. So then I would write this trinomial factors into 2 binomials. Write out your factors. The leading term is x for both. But then notice that they're the same. So when they're the same, they want you to write it out as 1 binomial squared. All right. Let's do a few more. Let's look at number 37. 37 is x squared minus 2x plus 1. Same process. I'm going to multiply to my c, which is equal to 1. Add to my b, which is equal to negative 2. Trinomial factors into two binomials where the leading term is x. I'm going to go through all my multiples of 1, and all I got is 1. So since I'm multiplying to a positive but adding to a negative, that tells me both of them are going to be negative. So therefore, that does give me the negative 2 I want. So there it goes, minus 1, minus 1. And then we're just going to rewrite it as x minus 1 squared. All right, let's see what happens when the leading coefficient is not a 1. So let's look at number 46. 46 is 6x squared plus 5x minus 6. And on this one here, it's a little different. So it's not just the c. It's going to be, we're still going to multiply, but now we're going to multiply to our a times c. So in this case, 6 times negative 6 gives me negative 36. And I'm still going to add to my b, which happens to be 5. My trinomial will still factor into two binomials. My leading term is x. And now I'm going to multiply to 36. You have 1 and 36, 2 and 18, 3 and 12. And you don't have to do all these. If you already know the answer, you're good that way. And this will be 4 and 9 and 5, 6. Oh, and then 6 and 6. All right, and then from there, since it has to multiply to a negative, that tells you one of them is a negative. And since you're adding to a positive 5, that tells you the smaller number is the negative. But negative 1 plus 36 is 35. Negative 2 plus 18 is 16. Negative 3 plus 12 is 9. Negative 4 plus 9 is 5. And then this is 0. So this would be your winner right here. So I want to write negative 4 and positive 9. So because the leading coefficient of A is 6, the only thing you have to do to finish off your work is divide both of these factors by that A and simplify. So 4 6 simplifies to 2/3, and then 9 6 simplifies to 3/2. So all you're going to do now is take the denominator that's left, and it becomes your leading coefficient. So therefore, your final answer would be 3x minus 2, and this would be 2x plus 3. I find this way to be the easiest. The book does the AC method, so it breaks that trinomial into a 4-term polynomial, and then you factor by grouping like we did earlier. That's the way I was taught. There's another method called the tabular method, or also known the box method. I'm good with that. I understand that one as well. I just find I've taught all these methods to a whole bunch of students in my career, and they always tell me that this one is like the simplest way to just get the answer. So that's what I'm going to use, but you feel free to use any method that you're more comfortable with. All righty, so I'm going to do one more, and I think you pretty much have a good example of everything you need for the homework. So let's look at number 60. This one is a 3z plus 2 raised to the 5/3 minus 3z plus 2 raised to the 2/3. And this one simply says factor the following algebraic expressions. All right. Try and go about the best way here. Okay, so technically, these are both the exact same terms. So it's still 3z plus 2 and 3z plus 2. So just as if it was like x cubed plus x, and I would say, you know what, they both have an x in common, and you would look at the smallest exponent. Same concept here. These terms are exactly the same, and I'm going to look at the smallest exponent. I can take a 2/3 out of 2/3, and I can also take it out of a 5/3. So what I'm going to do as my greatest common factor, I'm going to write it as 3z plus 2 raised to the 2/3. And now I'm going to figure out what is left. All right. So in parentheses, so I factor this out. So if I take a 2/3 away from 5/3, so you're aware, 5/3 minus 2/3, because you're dividing, right? That would give me 3/3, which happens to equal 1. So I'm going to write it. So when I write this, it would be 3z plus 1, or sorry, 3z plus 2 to the 1 power. And then this right here, if I take this entire thing out, I'm left with a 1 as a placeholder because 3z plus 2 to the 2/3 divided by 3z plus 2 to the 2/3 would give me 1 as a placeholder. I can clean it up since the exponent was 1. So this will give me 3z, and then 2 minus 1 happens to just be 1. So this will be the final result. So I know this looks complicated, but treat it as the same thing. Treat these as if they were just regular x's. Look at the smallest exponent, pull that out as the term that you see, and then work it out. So you subtract it from this, see what you have left, and then there's a 1 left over in that spot, and then simplify. Right? That's probably the most complicated question there is on that homework, but other than that, that is pretty much it in 1.6. But as always, if you'll have more questions, feel free to ask and let me know. You can do by email, I don't mind. But until the next video, see you then.